Okay, I mentioned we're going to talk about Method Update Rule from EPA, and specifically Method 625 Method Validation Study for Automated SPE Disk Application. A little more detail about our agenda today. We'll talk about the Method Update Rule. We'll talk some round-robin work that we did for solid phase extraction testing. We'll talk about the validation process for the new 625.1, and we'll talk a little bit about the use of smaller samples. Well, a number of years ago, the EPA developed the Method Update Rule. It was actually introduced in 2015, and they accepted comments. There were 3 new methods in this, Method 624, 608, and 625. And why did the EPA feel the need to do this? Well, the Clean Water Act methods in particular were very old. Methods 608, 624, and 625 had been revised 20 to 30 years ago. Now, it may sound really abysmal, and it kind of was. They had some small updates along the way, but they hadn't been codified into the methodology. So, for example, packed columns for G work were still specified in these methods, whereas most folks, 99.9%, use capillary columns at this point in time. So it's needed incorporation of newer technology, more uniformity, and a clear definition of flexibility. So it was a lofty task and something that the EPA has been trying to do on a more regular basis. Technology changes so quickly. So about this specific rule, it was proposed in 2015. The revised rule, with many comments that had been submitted in the docket, was signed on December 15th of 2016 by the previous EPA administrator. January 21st, the rule was withdrawn for reconsideration by the new administration. On August 7th, the rule was signed by the new administrator. And August 28th, it was published in the Federal Register. So it is effective on September 27th, 2017, next week. So what does this mean? It means that the new methods can be used in a week's time. So what changed in these methods? Well, I'll give you just a brief overview. Method 608.3 incorporates surrogates and incorporates some ATP work that was done on disk SPE in 1995. So there's 20-something years of data out there using solid phase extraction for Method 608, and it is now codified within the method. Now you'll see a link here on these slides, and that's a link to a talk at NEMC, the National Environmental Monitoring Conference. There's an excellent session at this conference held in the first week of August that talked about some of the changes to the methods. So I refer you to the link to the slides that were given by Adrian Hanley for Method 608 to get more detailed information on what has changed. Method 624, now .1, volatiles by purge and trap, this formalized a lot of informal changes that have made throughout the years. So things like I mentioned, such as the change to capillary columns. And again, Harry McCarty did a great talk on that at NEMC, and you can go either to the NEMC site and look for these talks. They were on Monday of that week, or you can click on these links when we send the slides later. Method 625.1, semi-volatiles by GCS. A large number of surrogates have been added. Potential analyte list has been lengthened, and it's been organized. Rather than one huge table of possible analytes, there are tables 1, 2, and 3. Tables 1 and 2 include some of the analytes that were in the previous versions, and table 3 includes other analytes that may wish to be measured based on a particular permit or industrial category, and those are sort of the exception to the rule. And there is a validation procedure included for additional changes to the method outside of flexibility. Introduction to solid phase extraction. It's been developing for more than 3 decades and is well characterized, and you'll find it in the environmental area in both disc and cartridge formats. It's used extensively in environmental, mainly to capture the analytes and do some cleanup, but not strictly as a cleanup form. Although it provides significant benefit to laboratories, it's not clearly permitted to be used with some of the methods. So laboratories are reluctant to move forward unless they're assured that they can use technology that will be readily accepted by their auditors, and the technology is allowed for all samples, so implementation is cost-effective. Makes sense. This table shows some of the drinking water methods that allow solid phase extraction, and they really embraced the technology. So, for example, you see method 521. That's a method that looks at nitrosamines. That's one that's very popular. And this next set of methods in the table, you see 537 for perfluorinated alkyl acids. That has grown to be a very important method in drinking water and in other types of matrices. It's included in the SW846 sample prep method 3535A and can be coupled with determinative methods such as 8270, 8081, 8082, etc. So it's an important method in that program as well. And they're currently revising some of the methodology and incorporating language into it that specifically refers to this. Until this method update rule passed, the US EPA Method 608 was the only wastewater method that incorporated solid phase extraction. And I mentioned that was done through an alternative test procedure study in 1995. So although many methods do incorporate SPE, and we only talked about water methods, there are certainly air methods and other types of methods that incorporate it as well. It's more difficult unless there's a big method such as 625 that's a multi-analyte method for volatiles. It's more difficult for laboratories to justify the learning curve and the purchase of automation equipment. To summarize the problem, technology developers are unsure of how to proceed. We don't know whether we should follow an alternative technology procedure, which can be a lengthy and expensive procedure, or whether we should work with EPA to develop a new method. And laboratories would like to consider new technology, and I believe firmly they should have the opportunity to choose from a full suite of technologies and methodology to best serve their work specifically. But I'd like to consider it because it may be more efficient and less costly, and we're all taxpayers. So the first things we did was work with the American Council of Independent Laboratories, ACIL, through their nonprofit branch, the Independent Laboratories Institute, NPA, to develop a round-robin study with a variety of vendors. It was sort of a new paradigm, looking at a variety of vendors of solid phase extraction equipment and trying to understand how we could gain some data to show the EPA how SPE works. This is specifically for wastewater. So we got together and developed that, and this is what Horizon Technology moved forward with. The CDEX 4090 extractor was used with discs to extract the wastewater, and then the Drive app was used to dry the samples, removing any excess water, and also evaporating them. Now, we've replaced the SpeedX 4790 automation system with the SpeedX 5000. It's a new system that's been out about 6-8 months. And it shouldn't make any difference. You should be able to use either one because it's only a form of automation. We haven't changed the chemistry or the chemicals that are involved in the methodology. So that's not an issue. So here we show the Atlantic 8270 one-pass disc. This is a multimodal media disc which extracts bases, neutrals, and acids at pH 2. It eliminates sample basification and extraction. So you save time because you're only doing one extraction rather than two, and it avoids the possibility of emulsions. Couple that with a one-pass carbon cartridge to recover some of the light end and more difficult samples, analytes, and a dry disk separation membrane to remove the water from the extract. So it's really a very modern system using modern technology. And here we show the steps that are involved in the process. So the water is passed through the disk and through the carbon cartridge once and goes to waste. So that's done. The water's gone. And then we extract the disk twice, once for the two compounds, and then the second time for the ion exchange properties of the disk, and we extract the carbon cartridge. So all of those extracts, the two extracts, are concentrated with the dry VAP concentration system. Why do we do that? Well, we've got a challenging suite of analytes. They have a lot of different properties. So we want to make sure that we cover all of the properties of the analytes with solid phase extraction that we're doing. And in this chart, which is done for 8270 analytes, again, a full suite of, more than 115 analytes, and you can see the different colors. We've got the black for the ones that are retained on the carbon cartridge, the blue for the ones that are on the ion exchange cartridge, and the red for the ones that are done with the normal HLB components. You can see that the disk and the carbon cartridge combination are very effective at the full suite of analytes that are thrown at it. So this is important for 625 as well, because it's a large suite of analytes, and some of the compounds have different properties, and they're accommodated with this system. To show a little bit about the disk holder in this case, we used a fast flow disk holder for the 1 liter samples, because these samples sometimes have particulates in them. So they're a little bit more complex and disgusting, if I can say so, than a drinking water sample would be. So a fast flow disk holder allows you to put some filters on top of the SPE disk so that you retain the particulate for extraction, and yet you don't clog the disk. So it's really a very nice system, and you can see that when we ran these 1,000 ml samples, 200 ml extract volume, and it took us about 3 hours to extract, dry, and concentrate. Now we used smaller samples, and in some cases we used 100 ml samples, able to use the same process with a 47 millimeter disc holder and a small sample bottle. It had 80 mils of extract volume, and it took us less time, 1 hour and 30 minutes, to extract, dry, and concentrate the sample. So in those cases, we've gotten a very effective extraction system set up and good results from that. So we'll talk a little bit about the round robin that we did with the Independent Laboratories Institute. Approximately 65 compounds in the analyte list, representing acids, base neutrals, and pesticides, and used synthetic wastewater. We also used a CLP extract in the second round robin, so we did a variety of different kinds of matrices. So in this case, the sample extraction and analysis was done by each lab that we worked with. Some labs used the 100 ml small samples, and some used the larger 1 liter samples. So we had 12 sets of data representing 4 laboratories. And here we show a chart with colors on it, and I just mentioned that because I'll go through and define what you're looking at. The first 2 columns, the chart with the gold header, are the EPA Table 6 range of allowed recoveries. So, for example, for acenaphthene, 47 to 145% recovery is acceptable. Next to that, you see the ILI average percent recovery. In the second set of 2 columns, you see the low and the high of 12 laboratories, the 12 sets of data that we're looking at. And the third set of data, in the center, the average of those 12 data points, and then plus or minus 2 standard deviations. We wanted to see how tight that data was. Over the course of a variety of laboratories, you would expect the spread to be pretty large, but in fact, it's pretty decent compared to the EPA Table 6 in terms of what is allowed. Now, the colors are to help us more quickly identify how close we are to 100%. So the dark green is the closest to 100%, and then anything lower will move away from green to yellow, to orange, to red, and anything higher than 100% will move from light blue to dark blue and get to black eventually. So it's just a mechanism for us to help readily evaluate the numbers in the table. And certainly things stand out, like those red values in the first column that say D, and that's detection limit. So if you can detect the compound, it's acceptable in EPA Table 6 for those compounds. So here we have selected bases, and we move to selected acids. I'm not showing you an eye chart, just an idea, a flavor of how the different laboratories performed when pooled together. And again, I was very impressed that the results were so good. So we knew, and here we have pesticides, we included pesticides in that as well. So we really had a huge range of compounds of varying characteristics. So round robin go, the interlaboratory study results were very good. Both large and small samples performed well. And the fact that we used a one-pass system with the newest technology for a disk and also for drying was shown to work well in a variety of laboratories. We'll move on then to the method update rule and what they say, 625.1, for flexibility. Subphase extraction or another allowed method modification is to be applied to a specific discharge. Laboratory must prepare and analyze matrix spike duplicate samples, and other criteria. So really what they're asking for is a validation of the specific equipment that will be used in the laboratory. I wasn't really familiar about this. This was a new approach of validation within a method. So Lem Walker was kind enough to write up a classification document, and at the bottom you can see that I have the website for that final version of the document cited, but he wanted to make it clear what exactly was required to do a validation study. So you can see the part that's yellow here, vendor performed study, all labs, all matrix types, and that's what Horizon Technology set out to do. So prepared the samples at the Horizon Technology Laboratory in Salem, New Hampshire, and worked with Environmental Science Corporation, Lab Sciences, a subsidiary of Pace Analytical. We worked with them for analysis and generation of the data package. They're an accredited laboratory and, are much more familiar with generating data packages than we would ever be. We concentrated on Table 1 and Table 2 compounds, and we used 1 liter samples. Here you can see some of the samples actually at work. So we've got a number of things going on. We've got particulates in the fast flow holder. We've got all sorts of solutions being reduced in the dry vat. So it really was a very busy time. And we had a variety of wastewater types from different MPDES categories to process. So from synthetic wastewater and seawater to POTW influence and effluents, and then we also spiked one with oil and grease to be sure that we met the criteria for an extraordinary sample. We had industrial effluents from different categories. The formulating point source category was nasty. So was the centralized waste treatment point source category. I was very surprised at how nasty they could be. One of the things that's different in method 625.1 is surrogates. One of the things that came out of the round-robin work that we did early on with the EPA was they realized that the surrogates that were included in the old method 625 were not adequately showing performance of the method while it was being run. So additional deuterated surrogates were added to the method to better monitor performance during run. And I show you the list here of the optional surrogates that can be included. And we included quite a few in our analysis so that we were complying with the newest version of method 625. So just to show you some selected compounds data, this is a chart summarizing the percent recovery of the CCVs over the course of the analysis ESC. This was a sample that was run by them to ensure that their system was in compliance during the run of the methodology. And to make it easier to observe, I've put a yellow column at the end with a pass-fail. And you can see that their system was in compliance throughout the analysis. This is a little bit more of an eye chart. This is the demonstration of compliance required. And we've got 4 samples. Had to do some different dilutions to ensure that they met their criteria for internal standard recoveries. And you can see that the recovery is within the path range, as is the limit for the standard deviation. We also determined method detection limits, and the method detection limits are compared in the last 2 columns with the method detection limits in 625, the original version. And you see that in most cases, they're dramatically better. In some cases, not dramatically better, but in most cases. Our worst wastewaters is shown here, and you can see they had to do an additional dilution of 20x in order to get the internal standard to pass. The rate and the relative percent difference was excellent for the matrix spike and the matrix spike duplicate. Ran into a bit of a challenge when it came to performance samples. I talked to Finova and said, you know, let us in this clarification document that we need to run a performance sample for each analyte that we're interested in demonstrating complies with the requirements for validation. And I said, can't do that. And I said, and these normal performance testing samples have only 60% of the compounds in any one set, and that's to meet NELAC criteria. If all the compounds were in there, it would be easy to cheat. So basically, they put 60% of the compounds in there, and you have to get them right. So I said, well, now I'm kind of between a rock and a hard place. How am I going to comply with the requirements when I can't get what I need for the performance testing? So he looked in their performance test samples to see how many I would need to cover the full suite of analytes. That didn't work so well. We worked with them to provide one performance test sample with the 60% of the compounds of interest, and also a certified material with all of the compounds at one concentration. So I think between the two, we'll have shown very adequately that we have met this criteria. And I haven't gotten any pushback from EPA on this point. So the results of the performance sample with the varying concentrations for a selected set of analytes, and you can see that we did very well with analytes that were present. And this is the performance sample with all of the analytes in it at one specific concentration. And again, the recoveries are very good. that we adequately met all the criteria of the clarification document that Lem had generated, showing that we can meet the criteria with solid phase extraction of 75.1. Now, labs wish to move towards handling and analysis of smaller sample sizes. It's easier to handle and store small samples. It's low shipping cost, faster extraction time, less solvent is needed for extraction, and less solvent vapors are generated during evaporation. So there's a lot of reasons to go to smaller samples. And in the meetings that we had with EPA early on, there was no concern about homogeneity. One of the people brought it up and everybody said, nope, they've never seen any problems with homogeneity, so that shouldn't be an issue. Smaller samples should be fine. They are already allowed in some methods. Ones that require automatic sampling will generally only collect 250 milliliters, not a full liter. So it's entirely possible that we'll all move towards smaller samples in the future. Selection of 100 ml samples were also run to supplement the information on large samples. We ran spiked reagent water, synthetic wastewater, and a TCLP matrix. They were prepared in Salem, New Hampshire, in our laboratory, and then analyzed by Shimadzu in Maryland, and that was included in the data package as well. Just to show you some of the data, again, we have selected compounds. This is synthetic wastewater that has been spiked. This is not with a reference material, but with a standard. And again, the averages, standard deviation, RSDs are good. And you would expect that perhaps going to smaller samples, you might see that the standard deviations just have more noise in them because you've got less sensitivity, so you may have more noise. But I think they look very respectable. This is a selected set of acids, again, pretty decent. So in conclusion on that, automated solid phase extraction using a one-pass disk met all the criteria specified in the new validation requirements in Method 625 included in the recently passed method update rule. It will challenge interpreting the requirements, especially when it comes to the performance materials section, although guidance document that EPA created was extremely helpful. The process was less intense than a full alternative test procedure, since only one laboratory was involved rather than 9. This also makes the cost more reasonable. The entire study could be completed in a more timely fashion since there's less coordination required. Additional work with smaller volumes demonstrates that improved GCMS performance extends the range of sample sizes that can be measured. I think that there can be more work done there as well. I mean, certainly people have talked about large volume injection. They've talked about adjusting the split. So rather than using a split, they could use a splitless injection of the sample. So there are a lot of ways to tweak the sensitivity to make it appropriate for these smaller samples. So the data package, amazingly, in my mind, includes 3,200 pages of material. It's available for instrument purchasers to demonstrate our system, the Horizon technology system, audit support for use of SPE as specified in the method. Now, I know some folks are probably thinking, well, I'd kind of like to get an overview of that, a little bit more information. So application note 117 summarizes the data and is available to everyone. That can be downloaded from our site, and we'll mail a link to everyone after this webcast. I'd also like to acknowledge and thank folks for a variety of wastewater samples. It was wonderful to have people offer those up so generously. I also would like to thank Shimadzu for helping us with the analysis. And Finova, Ty Garber, was very helpful, and of course our partners in this were ESC. And at this point, I would be happy to entertain questions. I see you have one question about, do you have any performance data for N-nitrosyl methylamine using the one-pass method? Yes, we do. And we can send an application note that shows that. Are there any other questions? Well, thank you very much for attending this webcast. If you have any additional questions, please send us an email and we would be happy to answer that. And we'll send a follow-up with a link to the application note. Thank you very much.